Good morning and welcome to this conference, the first Bowen Theory Academy conference that is live and also on Zoom. Our programs are generally, thank you, am I shorter? I guess I am. So our conferences from the start have been designed to be on video and on the internet. Part of the reason that Bowen Theory Academy started was to get out the thinking of Dr. Kerr and others, but particularly Dr. Kerr, on a webcast. And that was done back before 2011 when we were got our first program going. But that was the first program, and many of you are on the webcast, and we're very proud to have now the accessibility for people to hear Dr. Kerr across the country. And I know I heard from some people who were signing up that they were very thrilled and didn't know, actually, before hearing about this conference, that there was an opportunity around the country for people to get the webcast and or to go to a place where someone else across the country is seeing it. So that is the beginning of Bowen Theory Academy. And so here we are today, and during that time and during the webcast, we have been able to hear some of the thinking that Dr. Kerr has been doing over the period that he's been writing this book. And so it's wonderful to be timing our first live conference with the book. And notice that you do have an opportunity to get a discount. And if you take one of these sheets, you can order online. It would be a pre-order because the book will not be available, I am told, until February, but you can get that book. All right, so as far as things for the day, I think you all have the agenda. You can look at that. And if you have ordered lunch, it will be brought to you here, and we'll eat here. And so just remember that. And as far as signing in and signing out, if you're getting CEUs or credits, you need to sign in after the break and when you come back from lunch. So remember to do that. And as far as the other paperwork, you will need to sign the evaluation forms and fill them out and sign them. If you are here, hand them in before you go for each speaker. And then you'll get your credit. And if you are on Zoom, you know, I think you've been told that there is a process for this, and you have received these evaluations, and you will then send them back to Lori Kirkpatrick on our website, and she will be able to give you your credits online. So at this time, I want to make sure we get started right away. And our first presenter is, of course, the author of this book, and of course with Dr. Bowen, Family Evaluation, and that is Dr. Michael Kerr.
Just have to pull up my slides here. I'll just double click on it. Okay, good. This one. Oh, this one. Okay. Great, thanks. Okay, we're a little behind schedule. I'll try to make up some time, but I don't want to rush through this.
Should be you up there. Why is it not you? Okay.
As far as I know, it's me.
We're gonna go with this. There.
All right. Okay, so you see the title slightly in quotes because I bit off more than I could possibly chew in talking about toward a systems theory of cancer. It's the first time I've really concentrated on that in one presentation. But I didn't get very far. There's some new things here, but it's more, many of you have heard a lot of these ideas, but not organized in this particular way. See, I forget I didn't change slides on this thing. Okay, here we go. So I begin with two ideas to set the stage. Now, David Smithers is a radiation oncologist in England, since deceased, published this article in The Lancet in 1962. And I'm going to show a longish quote from that paper. What we need most at present is to develop an autonomous science of organismal organization, a social science of the human body, a science not so naive as to suppose its units, when isolated, will behave exactly as they do in the context of which they form a part. And willing to recognize that the whole functioning organisms are its proper concern. It will try to explain normal growth, differentiation, maintenance, and repair, as well as their disorders. It will take biological orderliness in action as its field of study. It lies in wait for a name between cytology and sociology. It is more than oncology, for it is the study of the organization of whole organisms, as well as that of disorganizational tumor foundation. It is biocybernetics, the science of organismal organization, the study of the foundation of life. Another quote from his article. I'm not used to this PC, so I'm having trouble. There is no such thing as a cancer cell, only cells behaving in a manner arbitrarily defined as being cancerous. There is no such thing as a... Oh, okay, that's easier. Familiar. All right. Thank you. There's no such thing as a schizophrenic, only people behaving in a manner arbitrarily defined as being schizophrenic. And that comes from Bowen's family systems theory. I think the idea here is that the cause of the problem does not lie within the individual organism, whether it be the cell or the human being, the human body. Requires an understanding of context in which it exists. Some of you may have read this book from 1946, Lauren Isley. And I like this quote for it's along the same lines. Men talk of matter and energy, of the struggle for existence that molds the shape of life. These things exist, it is true, but more delicate, elusive, quicker than fins in water is that mysterious principle known as organization, which leaves all other mysteries concerned with life stale and insignificant by comparison. For that without organization, life does not persist is obvious. Yet this organization itself is not strictly the product of life, nor of selection. I particularly like this part, like some dark and passing shadow within matter, like some dark and passing shadow within matter. It cups out the eye's small windows, or spaces the notes of a meadowlark's song in the interior of a mottled egg. That principle, I am beginning to suspect, was there before the living in the deeps of water. So this is his effort to grapple with the idea of organism, organization. So a historical perspective I thought would be useful. Many of you have heard of this famous French physiologist, Claude Bernard, who came up with the idea of du milieu intérieur back in the 19th century, which eventually, I think, came under the term homeostasis, that an organism had an ability to regulate itself in ways that could keep it in an adaptive state under changing surrounding circumstances. His contemporary was Louis Pasteur, and the germ theory of disease is something he discovered, and had the idea that the strength of the bacterial invasion is the prime determinant of symptoms developing. And I know to some degree in the extreme that holds, but it doesn't hold in all situations by a long shot. Bernard disagreed. He said the microbe leads to disease only if the body terrain is sufficiently disturbed. And on his deathbed, Pasteur is said to have said the following. You're supposed to laugh at that. Literally. Bernard was right. The microbe is nothing. The soil is everything. In other words, is it the individual organism, or organisms in this case, that create the disease? Or is it the conditions in which this organism is living play a critical role in whether it happens or not? And that's really the theme of this presentation. But that was lost sight of for medicine, I would say, has been dominated more by the cause and effect pathology model ever since. In 1992, an article I wrote, I expanded, I think, an idea of Murray Bowen's that I call a systems model of disease. Although physical, psychiatric, and behavioral disorders are considered manifestations of family emotional forces, such forces are not held to be the cause of an illness. The family doesn't cause somebody to be schizophrenic. An understanding of any illness must include pertinent facts derived from all levels of investigation, intracellular to societal. The interplay among all the factors must be examined, with no single factor or set of factors viewed as causal. A model that can incorporate all the facts and their interrelationship without ascribing cause to any one fact is what I call a systems model of disease. I borrowed the idea from Murray Bowen's hurricane idea, where you need 7 or 8 conditions to be met for a hurricane to come to be. This just emphasizes and understand the interaction of the many components and how they're altering each other's functioning is critical. So the next part is going to be familiar to many Bowen theorists. It's important, I think, to review it for this subject. Bowen theory has the concept of emotional regression, and basically what I'm trying to do is extend that concept to help us understand what cancer is. So most of you, there are 2 essential variables in the theory. Differentiation of self is one, and it describes a continuum of basic levels of differentiation for our species. And it appears to, the percentages in the population appear to come out to a bell-shaped curve. Now, this is an estimate based on clinical observation. So you see there the bell-shaped curve is showing a median of down around 40 or high 30s, with about 10% of people being above 50, and 50, 0 to 100 is just to designate many variations along a continuum, with the upper levels of 75 to 100 being hypothetical. When Dr. Bowen first wrote about this, he put people up in the 90 to 95 range, but then wrote later, with increasing experience with a wide range of people, there is evidence that most of the population is below 50 on the differentiation of self scale, that emotions are that powerful in most of us and can dominate over the ability to regulate and use rationality for long-term decision making. But there's variation in the 90% that are below 50, all the way down from the least to the most adaptive in that range. So this is a continuum of human adaptiveness. And it's thought to be created conceptually by a multi-generational transmission process that alters what are called basic levels of differentiation. And on the left side of that 4-generation diagram, with the lines coming down to the left side, the color blue is getting deeper and deeper, indicating a line of family where the levels of self are increasing. And on the right side, just the opposite, the levels of self are decreasing. So after 4 generations, there's a significant continuum of variation in differentiation or adaptiveness of members of the same multi-generational family. And this would be true of all families. That's important for this talk because chronic anxiety, the other central variable, the average levels of chronic anxiety vary with where people are on the continuum of differentiation. And that can be looked at multi-generationally. So here on the far right, you see the families getting a darker and darker red, indicating a higher average level of chronic anxiety. And if you move to the left side, that third family in the bottom row of families is a family with a much less average level of chronic anxiety because they can adapt better to life challenges. So they're not equivalent, but they're very interdependent variables. And chronic anxiety is, again, key to this presentation. So it's an interrelated but a distinct variable in the theory. So I pose this question to those of us who are Bowen theorists. How many accept the accuracy of this statement? All things being equal, a life course is determined by the amount of unresolved attachment to the family of origin, the amount of anxiety, average, that comes from it, and the way the anxiety is dealt with. I mean, that is one powerful statement that some might call fatalistic or deterministic. But this is at the core of the theory, that the unresolved attachment to the family, which affects the basic level of differentiation, is going to be associated with an average amount of chronic anxiety that's lower in the more adaptive people. And then there are ways it's dealt with that it manifests. And one way it manifests is in symptom development. So thinking about this idea is important for the idea of an open relationship. This came from a video interview I did with Dr. Bowen in the mid-'80s, where he said this: one can communicate his or her innermost thoughts and feelings to the other without fear of hurting the other, and the other can do the same. If a person has this with at least one other person, it is ideal, it promotes health. And in that video, he showed how hard it is to have this. Most people have it in a courtship, and all of us to one degree or another emotional distance creeps into a marriage, and to one degree or another, depending on differentiation of self. Esther Sternberg, a well-known stress researcher, picks up on this point. The effects of these personal connections can be more soothing than an hour of meditation. They can also be as stressful and more long-lived as running at top speed for 20 minutes on a treadmill. So this is another, I think, unique idea in biology, as well as family, that Bowen developed. The idea that relationships function as if is important. This is a concept. They're governed by two equally intense, counterbalancing life forces. One is individuality, which is a built-in life growth force toward individuality and the differentiation of a separate self. Instinctively rooted, but development hugely important in that differentiation of a self. And the togetherness life force derived from the universal need for love, approval, emotional closeness, and agreement. That both are always at work in a reciprocal fashion. So the overall thesis I've been talking about so far is that multi-generational emotional process generates variation in levels of emotional functioning that significantly affect level of chronic anxiety and life adjustment. So this is universal across cultures, is the idea. A high level of chronic anxiety disturbs family homeostasis and triggers emotional regression if coping mechanisms get overloaded to deal with it. The anxiety is disproportionately absorbed by one family member. And this is probably the hardest thing to grasp about Bowen theory. The vulnerable member is governed by the family's patterns for coping with anxiety, which that member participates equally in. Chronic anxiety can then disturb that person's homeostasis. This is the thesis here, which manifests as a disturbance in organ and tissue functioning somewhere in the body. So a way I've defined regression, if chronic anxiety escalates in a relationship system, the system becomes dominated by less thoughtful and more reactive ways of interacting that are older in an evolutionary sense than the advanced complex behaviors of a well-functioning relationship system. So just a series of diagrams just to illustrate this graphically. There you see a father and a mother with two children, an older daughter, a younger son. The dashed blue lines between them indicate that they're relating calmly, fairly calmly to one another, not triggering a lot of emotional reactivity and intense feeling states, but it's a positive environment. So we call this a relationship system in balance. And that means the functional level of differentiation is up. And any family theoretically can achieve this. It's easier for a more adaptive family than it is for a poorly adaptive family. And the next thing that can happen, of course, is a stressor or series of stressors that affect one or four more family members. It can be just one. And that alters family interactions in a way that people begin to relate to one another in a more anxious way, which is something easy to lose sight of. So that's referred to as an anxiety-driven disturbance in the balance of a relationship system. And that's the beginning decline in functional level. The more adaptive the family, the more stress it can deal with without that happening. The less adaptive, the less likely there are to adapt, to not experience that disturbance in system balance. So chronic anxiety escalates based on how the components of a system, people in this case, are interacting with each other not as a consequence of the original stressors. And that's an important idea. What I'm presenting here really is a way to think about things more than anything else that is still in the theoretical realm, but supported by clinical observation primarily and increasing knowledge in the sciences to a degree. So I borrowed another idea from Bowen and modified it a little bit, that these are the things, approval and attention and expectations and distress are the things most people try to work on when they're trying to work to be more of a self in a system. And it's hyperreaction of these sensitivities that can push people over the edge and put them in a more automatic reactive state. But also you have the cognitive-based, but not totally, ability to self-regulate these reactions, to process them on a, in a level higher in the brain and have still the choice of going with a feeling reaction or thinking through with a long-term view. So as family anxiety increases in a system, the reactivity to these social cues, as I like to call them, increases, which I show that here in red. And over time, that can result in overriding that ability to self-regulate, and things really begin to snowball. So a disturbance in the balance of a relationship system generates chronic anxiety, but then chronic anxiety disturbs a relationship system balance. It's a double-edged sword. So this is a system now in an emotional regression that has a significant decline in functional level. So I show the anxiety in the interactions and the red in each of the squares and circles to indicate the potential for chronic anxiety to build up in one or more of these individuals. Just to summarize, again, we're talking about quantitative differences between people and families, not qualitative. So in the bottom diagram, I show dots around the male and the female and an interactive process between them. The dots indicate permeable emotional boundaries, meaning people are highly reactive, very highly reactive to one another. And that can be a reciprocal interactive process. And it's based on high reactivity to these issues of attention, approval, expectations, and distress. Perhaps somebody would add another to that list, but this is the four I tend to see. And also a low level of self-regulation with a background of uncertainty. So that is a recipe for the much easier buildup of chronic anxiety in face of some kind of a stressor, internal or external, in the relationship system. Where at the top, the people are quantitatively different, but not qualitatively. All families, all people have much more in common than make us different. But the reactivity to these same social cues is less, and that's true for both partners, because they tend to mate for that reason, in the theory. And a more ability developed through, in the developmental period, to self-regulate that reactivity and not necessarily react automatically to its presence, to be able to see the distinction between a feeling and a more fact-based view of what's going on around you and in you. So again, that's the outcome. This variation is the outcome of a multi-generational process with many, many variations in between. And chronic anxiety is less predictable because the stressors that a family's going to be facing are less predictable, and how isolated they become, both of which aggravate the process. So I pose the question to myself, what does it mean exactly, a disturbance in the balance of a relationship system? What is the balance that is disturbed? This is my way of presenting that. The fundamental source of anxiety that can drive emotional regressions and ultimately fuel symptom development appears to be threats to the balance between sufficient emotional contact and sufficient emotional distance. I continue to ask myself the question, is it really that simple? It seems that basic. Contact and distance, and that's been talked about by others through the century, really. So what makes striking a balance more difficult? It appears that the intensification of the fusion or togetherness process, which relates to a decline in functional level of differentiation, is what makes it more difficult for people to balance contact and distance successfully. For example, if you watch a rhesus macaque with its offspring, and the offspring is beginning to separate from the mother to go out and explore, then gets frightened, what does it do? It runs back immediately to the mother for physical contact and proximity, and that can calm that individual down. And I think togetherness process is very similar. It's the go-to when things are getting anxious. So for example, as anxiety increases, one person may experience an increased sense of responsibility for the other's distress, and at the same time experience a compelling urge to avoid the other person. Therein lies a dilemma that's harder to negotiate for people who are lower in the adaptive range. So increasing togetherness pressure occurs in response to increasing anxiety and reflects an attempt to restore system balance. It seems to be what the reason for it is, or what the function of it is. If a comfortable balance is not restored, patterns of emotional functioning get activated to stabilize the now somewhat strained system. So, to summarize this, keys to understanding symptom development in a family are: one, the system-generated buildup of chronic anxiety, and number two, the patterns of emotional functioning that are activated to cope with that buildup. I'll describe those briefly. So in reading E.O. Wilson's book on sociobiology back in the late 70s and 80s, after I started reading it, this is what struck me, that the patterns of emotional functioning Bowen described in human families are similar to relationship patterns you could observe in many other species. The easiest to observe would be emotional distance, symbolized by the cut in the lines between the male and the female in that picture. When the people are getting anxious and dealing with each other, it's easy to just pull away psychologically or physically to reduce that reactivity. So it's a coping pattern. Or that anxiety can be externalized. And I thought one of the great insights of Bowen was the emotional conflict can be a way of staying in contact with somebody and pushing them away at the same time. So it solves that contact distance dilemma in that way. People are constantly in contact, maybe inside their heads about what's wrong with the other and ready to jump on X, Y, or Z. Or the more deferential pattern, where on the left there I show a female-dominated marriage, on the right a male-dominated marriage, and now call this the dominant adaptive or deferential pattern. So the male on the left would be the more deferential, the female on the right would be the more deferential. And this presumably is true in matriarchal or patriarchal societies. It's not a cultural thing. It's more an emotional thing you can see in other forms of life. And the triangle, which may be the most important of the patterns. Two people can explain the tensions between themselves by blaming it on a third person. That's why we're so anxious with each other, because of what the third is doing. And that can stabilize the twosome. So, as is true in other species, up to a certain level of activity, these patterns can help stabilize a system. But when chronic anxiety escalates, the intensity of the patterns can contribute to symptom development, manifesting in mind, body, or behavior. So with emotional distance, that generally operates in all four patterns. With emotional conflict, it's the anxieties are externalized into the interaction. It's not contained so much within the individuals, but spewed out into the way they deal with one another. It's not quiet, it's argumentative, and can reach physical violences, I'm sure you know. In the dominant adaptive pattern, my way of understanding that is that the one making the most adjustments internally to try to keep the relationship in harmony. And that'll often be explained by, I can't stand conflict, I can't stand the other's anger at me. It's easier to go along and avoid a fight, even though I pay somewhat of a price for that, perhaps. But when the anxiety is high in the system, that can lead to the person feeling isolated and somewhat out of control and in despair related to that. And that can be the kind of threats that fuel the buildup of anxiety in that individual. And important to emphasize that that anxiety has been absorbed from the family interactive process. It's not just a product of that individual. And the triangle, where the third one, the one who's seen as the cause, becomes the outsider. And that can leave them feeling out of control, in despair, anxious, and become vulnerable to symptoms. So to try to pull this together, again in a diagram, I distinguish a pathology-driven versus a system anxiety-driven model. So on the left, you see the P here indicates a potential for pathology developing in the organism. And this is a abbreviated family organism of 2 parents, 1 child. The dotted lines, arrows, indicate that there isn't much conceptual framework about that until Bowen theory came along. But it was there in Freud's ideas that what went on developmentally with the parents could create potential problems he called psychopathology that could manifest in symptoms in the near term or in the long term. But of course, genetics is also in the picture. That can never be ruled out as playing a role. So this potential for pathology can be biological or psychological or both, interrelated. So let's say this person moves into the adult world not having been terribly symptomatic as a youngster. That begins to encounter stressors in life. Those stressors then are thought by some to activate the pathology. And once that pathology is activated, it's running the show. It's the cause, if we go back to Pasteur, of the signs and symptoms that are playing out in that individual. So naturally, if that's the model, you focus on treating the pathology. Here is a different, this is a Bowen theory related or systems model where I show these arrows between people to indicate we do now have a conceptual framework for looking at more than a 2-person system, a 3-person system and beyond, and more understanding of how these vulnerabilities then can develop in the individual growing up in that situation. So, but here I'm calling it a V, which I'll explain later. It's a vulnerability that can develop, again, that can have biological and psychological elements. Genes are in the picture. So this person, let's say, leaves home being relatively, again, asymptomatic, although he could have been acting out as a kid vigorously, and meets somebody else who brings her set of vulnerabilities to the relationship. And in an interactive process, in the beginning, they're doing fairly well. Courtship and new marriage, for all of us, tends to be a lot easier than when things, responsibilities, and kids, and everything else gets piled in on top of it later. So here I'm showing that a child is born, and that creates a challenge for the system to adapt. How well it adapts, again, depends on the basic level in the system. And so I'm showing here a buildup of chronic anxiety with each person having their particular vulnerabilities that were the product of genes, development, and what have you. At this point, I'm showing it evenly distributed in the system. But on the right here, the patterns of emotional functioning come into play, let's say, where the wife becomes the more dominant partner. The husband becomes, in this case, the more deferential partner. Usually there's an over-functioning component in that to which he's doing, and under-functioning with it. The husband, and then the kid is more left out of it, so that he, in that way, absorbs chronic anxiety from the relationship system, and that chronic anxiety becomes the fuel for the vulnerability. It's not a pathology, it's a vulnerability that is fueled by chronic anxiety. It comes not just from that individual, but from the system as a whole. So it's a big shift from the individual pathology model to the systems model. Jaak Panksepp has a lot of interesting ideas. The recently deceased Dr. Panksepp. But he expresses what can happen in a human being. He studied emotional systems in details, written books about it. That people can exist in an affective comfort zone, or at the other extreme, an extreme emotional disequilibrium. I've added the piece below is that as people shift along this continuum, then it's going to have an impact, we now know, on alterations in the pituitary adrenal axis, the autonomic nervous system, and what Candace Pert called the psychosomatic information network, neuropeptides. So on average, the better differentiated or better adaptive people are going to spend more time on the left, the less well differentiated people, more time on the right, those families. So because it's emotionally based, mental, physical, and behavioral symptoms are called emotional disorders in Bowen theory. So that this disorder, though, because the anxiety is absorbed out of the system, not just a product of the individual, it's called a disorder of the family emotional system, whether it be ulcerative colitis, depression, or drug abuse. So again, the arrow just emphasized that the people can go back and forth that can either represent a change in functional level and regressions, but also on average, the better adaptive people will spend more time on the left side than on the right. But that again is a quantitative, not a qualitative difference between human beings. So finally to cancer. And, I decided early on, if I thought the role of emotional process and the variable of chronic anxiety played a role in cancer, I better get better educated to whatever degree I have in what the biology of cancer is all about, because is it consistent with this idea? And I wouldn't be presenting this today if I didn't think it was, but it's not proven. I first got interested in this when I started seeing cancer patients with larger numbers back in the mid-70s and stumbled on an article by a pathologist at Michigan about heredity and cancer. It was in the 1913 Journal Archives of Internal Medicine, where Dr. Warthen wrote the following: a family showing the occurrence of carcinoma in several generations, there is a decided tendency for the neoplasm to develop at an earlier age in the members of the youngest generations. In this case, the neoplasm often shows an increased malignancy. So if you look at this one in the center, for example, this comes from the text of his article. The grandfather of this granddaughter developed a cancer at age 74. The mother of this granddaughter developed cancer at age 59, and then the granddaughter at age 38. So he was observing this kind of pattern, increasing severity of the disease, but also earlier age of onset. So I thought that's what Bowen talked about in schizophrenia, and this got me thinking, are we looking here at one manifestation of multi-generational emotional process that is somehow affecting the cancer process in general, not just the specific cancers? Because you can see there's all different kind of cancers there, uterus, breast, tongue, stomach, etc. So to bring you up to date kind of the hallmarks of cancer in the next generation is a very well-read paper by Doug Hanrahan and Bob Weinberg. It was in Cell. They did the second paper in Cell in 2011. They had done an earlier paper, I think 9 years ago. So the one in 2011 was an update. And the main thing, well, I'll put this in because I think it's just intriguing. I love this quote: life is just self-renewal and differentiation. It's stem cell biologist. So there you see a stem cell. It can divide, and when it divides, it creates a cell that retains the potential for complete self-renewal. And then another daughter cell that begins to take steps internally in the genes and whatever's controlling that toward differentiation. And there are multiple feedback loops between all these cells in the architecture of a tissue to help regulate it. And that this regulation, of course, is a highly complex process for it to work right and to understand, as Smithers was getting at, if you understand what it's like when it's working right, it's easier to understand what's gone wrong when it's producing some aberrant change in structure or like a cancer. So one of the things they emphasized, Weinberg and Hanrahan, is again to think of cancer as a colony of many different types of cells, many of which, but not all, are produced by what they're now called cancer stem cells. There's one here. They have been discovered in most cancers, but not all yet. And then they divide and produce the daughter cells that can begin a path toward differentiation or not. They can be blocked in maturation. But we know also that the immune system, inflammatory cells, play a key role in how these cancer cells behave. And then some of the cells invade, and some key immune system cells can aid the metastatic cell or kill the metastatic cell, depending on the signals it's getting. And these are cells involved in the blood vessels, which can increase blood flow, which is needed to help this tumor grow. And then there are cells called fibroblasts in the tumor that are altered when they're surrounding a cancer. So this is an effort, I think, to look at the tumor in a context of cells. And Richmond Prain suggested this idea a long time ago. A tumor behaves in its patterns of growth like an integrated organ rather than a collection of independently growing cells. Tumor growth tends to slow progressively as size increases and undergo compensatory growth after partial resection. I found that particularly interesting, the point about tumor growth tends to slow progressively as size increases. as if it has some self-regulatory ability, but also that it's depending heavily on what's going on in the environment around it. Candace Pert expands that. She was a very fine thinker, I believe. She's now deceased as well. Was the cancerous tumor really part of a network receiving and sending information that linked it to the brain and the immune system? The link provides a mechanism by which these body systems may regulate, control, promote, or retard the actions of one another. In other words, the cancer, what it's doing, can't be understood out of the context of the larger body, and particularly those two systems related to the brain and the immune system. Minna Bissell, I think, has led a lot of this research. It's brought context back into focus. She wrote this in 2005. Just as tissue architecture and function are connected reciprocally and dynamically, restoring normal tissue structure to tumor cells can restore normal tissue function, even when the cells contain considerable underlying genomic aberrations, challenging the idea that the cancer is the result of gene mutations that drive so-called oncogenes, that drive the tumor's actions. And she's been showing that that's not really the case. There's a lot more to it than that, just as Bernard was getting at. Therefore, phenotype could dominate the genotype. In other words, the genes will behave if the cell behaves in malignant cells as it does in normal tissues, because the genes in different tissues and organs are identical, yet the phenotypes are distinct. So phenotype and genotype can be quite a discrepancy in how that's explained. So I put this in just because of medical research is the way it is. The role played by the microenvironment in providing a congenial soil, remember Pasteur's lament, was identified at the end of the 19th century by Stephen Paget, but the discovery later of tumor viruses, oncogenes, tumor suppressors in the 20th century overshadowed these earlier studies, as most workers pursued cell autonomous mechanisms for cancer initiation, progression, and metastasis. They're looking at the cell in part because it's hard to study communities of cells, but that detracted attention to what Paget was getting at and what Bissell was describing. So I just throw this in to show that this is an organized architecture of the skin. And all these cells are tightly interconnected, communicating big time in ways we partially understand with one another and keep each other in line and regulate each other. So that whole process from the stem cell of the adult tissue dividing and then the process toward differentiation and normal differentiation by the time they reach the top of the skin is all regulated by the environment in which they're growing. So Bissell adds this: key questions in cell and tumor biology include how tissues and organs maintain homeostasis, not just cells, but tissues and organs, I would say people. I think Mike Lumpkin is going to talk some about that today, but also, of course, with Bowen theory, expanded to the family as having a powerful influence on the people. So how cells within organisms lose or overcome these controls in cancer. Pithy quotes from Dr. Bissell: cells keep each other in line. Mechanical forces triggered by cells pressing up against each other can have a calming effect on cancer. I found an interesting choice of words. Putting breast cancer cells under gentle pressure, akin to what they might encounter growing in a healthy breast, causes them to reconnect with their neighbors and behave like non-cancerous cells. It's tempting. It's only an analogy to the human condition, but there may be more to it. They receive many cues from the environment about how to behave, as do humans, dogs, and other forms of life. Cancer is not a problem of growth, as the field believes. It's a matter of context. Place a cancer cell in a normal environment and it becomes normal. Place a normal cell in a cancer environment and it becomes cancerous. Send an asthmatic child to camp in Denver for the summer. The asthma gets better, gets back home for the fall, it gets worse. It's so obvious, she says, why don't people get it? Reminded me of something Bowen might say. It is obvious, but not obvious. So toward the end of this, I wanted to just talk about how I got to this regression hypothesis. And this particular study, published in PLOS Medicine in 2006 by Alvin Coe, really caught my attention. This is a chest x-ray, of course, and you see the square there, which indicates that there's a tumor growing here. And it could be a small cell tumor, it could be a squamous cell tumor, adenocarcinoma, carcinoid. And I'll talk about why that's important in prognosis. So what he did, they went to the literature. There's a huge literature apparently on mouse lung development, and figured out which genes are active at what points in the development of a lung during embryogenesis. And I symbolize the essence of his idea is that the earlier the lung is in the development, genes A are being expressed far more than B, C, and D. And they could be genes for simply self-replication, perhaps. As you move to the right and migration becomes important, then A may be a little less important and B begins to dominate. As you move farther, now you're moving toward the beginnings of differentiation of cells toward a mature lung cell, and then to the A, B, C, D in red, and then finally the adult tissue. And in comparing human cancers with mouse lungs, the lung cancers in humans, they found over 500 genes overlapped. And that was the basis of this study, I think, the way I understood it. So the carcinoid is generally, when they looked at carcinoids, the genes expressed in the carcinoid cancer were genes normally associated with late development of the lung. With the adenocarcinoma, and there's variation within adenocarcinomas, but overall this was the pattern, the genes active in the tumor are ones that are usually active a little more earlier in development. Squamous cell earlier still, and small cell, the earliest genes that are active in development are the most active in the small cell. This is important because this associates with an increase in aggressiveness. Again, the way I think about that potentially is, does this represent an increasing level of regression? You go from more complex to less complex, and you get into a more aggressive, disorganized process. Again, only a hypothesis. Atavistic model of cancer kind of encouraged me. Paul Davies and Charlie Lineweaver published this paper in 2011. He's a physicist. He's an astrophysicist. The Cancer Institute paid them a lot of money to study cancer. Why a physicist? Well, because the cancer needed some help, and they thought physicists are good at solving problems. So they came up with these ideas. Cancer cells are cells that have become deregulated and default back to ancestral pathways, just like Coe was talking about. But also they take it back even farther in evolution, and I'll come back to that. So the cancer phenotype, as Coe was saying, is expressed in early embryogenesis, but these genes apparently are some of the oldest in the phylogenetic history of the species. Cancer is not running on defective genes or oncogenes, but perfectly normal genes, what he calls an ancient cassette. They are upregulated inappropriately. The genes are still there because if you want to have an embryo develop, you need these genes. or if you cut yourself and need wound healing, these genes must become active to help you heal, because in the wound healing, you get increased cell replication, migration, and then differentiation, just like in development. And then when it's healed, it shuts down. Cancer cells look like monster cells, a mess, aneuploidy. Cancer looks too efficient and deterministic to be just an accident. It looks like a pre-programmed response to some stress. Now, they don't speculate about psychological stress. When I first got interested in cancer, I was riding in the car with Murray Bowen. We were riding down Foxhall Road. I don't know why I remember that, but we were. And he says, you know, the war on cancer had just started. And he said, cancer is not a disease. It's something in nature we have to understand. And that stayed with me, and I think that's what they're getting at here. Gene mutations would be a byproduct of cancer, at least most of them. The more disorganized the cell, the less the genes are organized in the DNA structure. So cancer is a rerun of embryogenesis, but not well ordered. It's, I would call it regressed. Things are not running smoothly, but it's also something that's been around for a long time. Support for this comes from a recent article, 2014. This is a hydra. It's one of the oldest multicellular organisms on Earth. This is a hydra with a cancer sticking out, bulging there. And Professor Bosch, who is on the research team, cancer is as old as multicellular life on Earth and will probably never be completely eradicated. I think that's what Bowen was getting at. Chronic inflammation, more and more people aware how important that is, and not only cancer, but a whole host of diseases. Mike Lumpkin will, I'm sure, include a fair amount about that when he talks this afternoon. But this is borrowed from Chuck Bresson and Andrew Miller. Just that, you know, the stress, you could say it begins with a perception in the brain, psychological stress, the perception of threat, and then it activates these various pathways, particularly the so-called hypothalamic pituitary adrenal axis. The cortisol is the well-known hormone, but also the autonomic nervous system, which I'll keep returning to. Through the sympathetic chain, it shows there at the very bottom. And then I show this slide because just to emphasize, this is a macrophage, and this is indicating a nuclear factor kappa beta that can actually influence the regulation of genes in the macrophage and help it change phenotypes into a more pro-inflammatory state. So instead of inhibiting or instructing other cells to inhibit or attack a cancer, it can actually support helping the cancer migrate into the bloodstream, for example. I mean, who'd have known macrophages were supposed to be our friends? And now we find that they can be just as dangerous as they are helpful in certain conditions. Bruce McEwen, I like this quote, "For the most part, only humans can keep this hypothalamic pituitary axis going indefinitely. We can do this because of how our faculties of perception, thought, and emotion are produced in the brain and how they are connected to the stress response. We may be unique in our ability in that regard." This comes from, this is a colon, slice of the colon, and up here is normal looking colon, labeled with N. Here's the colonic cancer. You can see the change in the colors of the cells in there, indicating more activity, but you can also see the changes in the connective tissue that surrounds it. That's called tumor-associated stroma or connective tissue. Was long known that the cancer cells send out signals to alter the context in which they're in that helps them progress. But now it's much more known that it's a two-way process, And some stem cell researchers, for example, are saying, we don't know where this starts. Is it the tissue that changes and that leads to the cancer? Or does the cancer change? I used to say that about psoriasis, but I think the best way to look at it is they influence each other. It's hard to say where the cause is, but it's important to understand because like in psoriasis, they've been able to block some of these immune system cytokines and have dramatic improvements in symptoms of psoriatic patients, and perhaps that can be refined more and more for cancer. So Richmond Crane again, most benign lesions do not transform to malignancy, and many regress. Cell-to-cell or cell-to-matrix interactions appear to be the major inhibitors of tumor growth, just like Purcell was saying. Immunostimulation may be an interference with cell-to-cell or cell-to-matrix communication by what he calls a sublethal immune reaction. Instead of the immune system killing cancer cells, it's actually disturbing the interactions between them that help regulate them. So I clue in on that because it is a relationship system idea. Saying that the immunosurveillance theory is much overrated, that the immune system is supposed to kill cells, that in fact the immune system is a regulating system that can both stimulate and inhibit, and that seems pretty clearly true. But he also says it probably does both in cancer at different stages, and that's something we still don't know. So stress doesn't necessarily initiate cancer, but it may have a very important part in its growth at a particular point, and maybe not in the latter stages. Somewhere in there, I think, is the views I'm reading. So stress and cancer, and then this is the last section, I think. We started late, we still got a little time if we run over. So J.P. Henry, who had the privilege of meeting some years ago, chronic as well as acute emotional arousal is a consequence of various types of social interaction. He studies animals as well as humans and came to that conclusion. That's what Bowen theory is too. Social interaction, particularly within the family, is key. Walter B. Cannon gets credit for the homeostasis term, I think. Some of the characteristics he wrote about: any tendency toward change automatically meets with factors that resist change. Try differentiating a self and see how much help you get from your family members. It's automatic, been there, done that. Homeostasis does not occur by chance, but is the result of organized self-government. I think that harkens back to Isley's quote, and whatever that means. What does that look like? Selye probably has demonstrated the role of the stress response in causing or combating, both causing and combating much of the wear and tear experienced by human beings throughout their lives. Paul MacLean is given credit by McEwen for helping us understand that the brain is an emotional organ, and through his work on the limbic system. And this paved the way, according to McEwen, for demonstrating the link between connecting the emotions, the stress response, and the brain. And I'm trying to add specific diseases to that. Jack Pangsep again, in short, since we must interact with the world on a periodic basis to sustain bodily equilibrium, we have brain mechanisms to generate various forms of distress, hunger pangs, thirst, coldness, etc. When body resources deviate from equilibrium, and we feel pleasure and relief when we undertake acts that alleviate disequilibrium. To me, this helps appreciate how emotional reactivity can be so powerful. So does the same idea apply to emotional equilibrium, disequilibrium? Bowen theory would say yes, and that how much does chronic anxiety affect that process? It seems pretty clear looking at the family, and then how clear is it in the body? Still more to learn. So allostasis was a sort of another aspect of this. McEwen didn't originate this term, but developed it, and that's maintaining ability through change. So here's a person sitting in their living room, a comfortable chair, in a certain physiological state, it's homeostatic, decides to go up 2 floors to get a newspaper article or something he wants. In order to climb those 2 flights of stairs, something has to change physiologically or he won't make it, such as an increased cardiac output, cardiac rate. And then when he gets to the goal, that shuts down and there's a recovery period. This is not damaging. This is helpful. But allostatic load, it describes when this doesn't shut off. And nobody's quite sure all the factors that go into that. Bowen theory is adding a second set of factors, differentiation of self and chronic anxiety, that could play a role in sustaining or being part of allostatic load. It refers to the wear and tear that the body experiences due to repeated cycles of allostasis, as well as the inefficient turning on or shutting off of these responses. And Esther Sternberg's quote earlier, I think, treadmill quote was an example of that. And the slide here shows the glucocorticoids and the catecholamines like epinephrine, norepinephrine can get into the cells through the receptor systems the cells have, and then they can ultimately affect what's going on at the gene level. So the stress response, the brain determines when the body's inner equilibrium is disturbed. The brain initiates the actions that restore the balance. Furthermore, a chronic stress response in an organism can contribute to dysfunction in an organ or tissue. A chronic family stress response can contribute to dysfunction in a family member, would be the idea here. I put in Cacioppo and Cole's paper, people with few social ties are at increased risk for ischemic heart disease, cancer, cardiovascular, and GI, just to emphasize that it's not peculiar to one disease. And that's the diagram, which genes are active, which are inactive, showing that it's the genes in the isolated people that foster cell proliferation and things that are immunologically more active versus in the integrated group, which those genes were more downloaded. So they have concrete evidence of what's happening there. Steve Cole puts a lot of emphasis on the sympathetic nervous system. That regulates the function of virtually all organ systems. This is part of the autonomic. It gets activated in the stress response. SNS activation can regulate gene expression and cellular function in the tumor microenvironment through a variety of pathways. So when sympathetic activity is chronic, it can be influencing the context, the tissue around cells that could potentially become cancerous. The SNS, unlike other stress-activated neuroendocrine systems, such as the HPA, is easily activated by the mere anticipation of a threat, which is so much what chronic anxiety is about, anticipating a threat that maybe never happens. Anticipatory SNS threat responses often occur at thresholds below consciousness. So I call it the silent killer. Unlike the HPA, the SNS, those responses do not decay over time with repeated threat exposure. They don't habituate, makes it more dangerous. This is based on Cole's, and Mike Lumpkin might have other things to say about this, but it does seem to me that the sympathetic nervous system seems to be very important in chronic anxiety, and for these reasons. So, and he thinks that SNS activity exerts its most pronounced effects in the early stages of tumor progression as primary tumors interact with the surrounding environment. But maybe not bring on the tumor or be all that important later on. Like so many diseases, they seem to be so self-replicating and so feeding into the processes, so feed into each other, they're hard to stop. I just put this in because it's about chromatin and the idea that chromatin, which surrounds the DNA double helix, can actually play a key role in homeostasis of the genome, the way I interpret it, or it can be thrown off, and homeostasis at the level of the double helix and the chromatin that surrounds it can be thrown off and render that cell then vulnerable to cancer. So inflammation and aging and other factors can disrupt chromatin homeostasis. So there's inflammation again. And purely epigenetic stimuli can induce a change to cancer. The last slide, I just wanted to leave you with a picture. I did get this in an hour and 15 minutes, but we started late. I won't go into all the detail, but here's a nerve that is releasing a sympathetic nervous system, norepinephrine, noradrenaline, in the vicinity of the tumor, because the nerves grow into the tumor, and they're essential to its function. And then these release of this catecholamine can plug into receptors on the blood vessel that can change both the kind of metabolism the blood vessel has and affect the rate of cell division. And by speeding that up, then you're adding a greater blood supply to a tumor that is also asking for it. But then the result is the tumor can expand, and this nervous system is definitely a part of what's happening here. And again, with systems, the idea of what's causing what is agreeably hard to decipher. But it definitely, I think it helps seal the link between, if you can buy family affects the individual, and what's from threat, perceived threat, how that can actually affect cancer growth, at least at certain stages. So for that, I will stop. Thanks, and I know we're going to break now. And
yes, thank you. We're going to break now, and we'll come back at 10:40.
okay.
And then we'll be having a discussion later after the second part of our meeting. So hold the question.